Hello everybody. What if three complicated ratios suddenly collapse into a simple result? Sounds surprising, right? So in this video, we are going to solve such a problem with a proper thought process. We are given a problem statement where this equation is provided to us. And we need to prove that these ratios x by a, y by b, z by c are all equal. So in such problems, what is the thought process that should we have before jumping into the solution? So to convert the fractions with multiple terms into a simple fraction. So by direct addition, so if at all I try to apply the theorem on equal ratios, and if I try to add the numerators, there is no simplification since there is no common term to be cancelled. Second intuitive idea is, what if I take pairs and try to subtract? Even that doesn't help me out. But try to observe the proof part wherein we are supposed to come at this particular equation. And if you try to cross multiply these pairwise, these are the group terms that you get, which means that all these group terms should be equal to 0. So here we need to make the numerator 0. So rearranging is required so that the common terms can appear. But how do I observe these common terms? So observe the given equation. Here in the first term of the first ratio, you get to see ay. Now once again, where does this a appear again? So you see that in this third ratio, once again, you get to see minus of az. So by proper rearranging, so what will happen is if I try to multiply this first ratio by z and the third ratio by y, I can cancel out a few common terms. So that is where the intuition lies. That is, multiply the numerator and denominator of the first ratio by z, second by x, and the third by y, so that the terms align and they can cancel pairwise. So now let's come at the step-by-step solution. Let us assume that the given equation with the individual ratios is equal to k. Now let's multiply all these individual fractions or the ratios appropriately as we discussed in the intuitive part. So let's multiply the first ratio by z, the second one by x, and the third by y. Now by applying the theorem on equal ratios, we can add up the numerators and the denominators. Now expanding the numerator, what we observe is that there are many terms in common which can be cancelled out pairwise, and ultimately you observe that k is dropped to 0. See, we started assuming that all these ratios are equal to k and k itself is now 0. So we can equate each of these expressions or the ratios to 0. So now here, if I equate the first ratio to 0, we can say that the numerator itself is 0. That means ay is equal to bx. Likewise, if I equate the second ratio to 0, we can mention that bz is equal to cy. Now from 1 and 2, we can completely arrive at this particular statement. That is, x by a is equal to y by b is equal to z by c. Hence, we have proved the final result.